So, hello everybody. My name is Palo. I'm a solution architect at Alma Media, and I'm gonna talk about infrastructure as an actual code with AWS Cloud Development Kit. But before I do, just want to mention that this session is not live. So unfortunately, I wasn't able to perform it live as an online session. Instead, this is a pre-recorded talk. I recorded this on the previous weekend, but I'm gonna go through it as it were a live session. So I'm gonna go through my slides and also my demos live. So let's hope the demos go well. And also on that note, as this is not live session, I won't be doing the Q&A questions section after the talk. But instead, I'm gonna, at the end of the talk, I'm gonna have my contact information on the slides. So if you have any feedback or questions about the presentation, or you just want to connect with fellow cloud enthusiasts, feel free to connect with me. But yeah, let's get on with the presentation. First of all, a bit about my employer, Alma Media. As you might guess from the name, it's a media company. We have a lot of news websites. We have also a lot of customer and business-facing digital services. We have headquarters in Helsinki, Finland, but we operate also in Sweden and Eastern Central Europe. In total, we have around 280 developers, of which 150 or so are in Finland. In Finland, we also reach about 80% of Finnish population, and that leads to 750 plus million page views per month. We love infrastructure as code. That's because we have somewhere around 100 AWS accounts, and we've been in AWS since around 2012 or something like that. We're also big fans of serverless. On that note, we have somewhere close to 2 billion Lambda function invocations per month. There's also in the right side, there's some of our Finnish brands on the map. Here's Alma, as I said, headquarters in Finland, Helsinki, and also we operate in several countries. Here's some key figures, the interesting one being the 100 plus websites and apps. DevOps Pro being the Lithuanian conference. You might know this CV Online, which is a Lithuanian recruitment service. That's our business as well. But me and my team, we work with Alma's Finnish brands. So today I'm talking about those. We create services and APIs that are shared between different services. We also do integrations between different systems. We also write utilities, libraries, tools, scripts, what have you. Also develop React.js and other UI or front-end components. So pretty full stack here, but key point being that those are components and services that are used throughout Alma's Finnish brand. So if you're visiting our, let's say some of our like news websites, your browser is going to execute some JavaScript made by our team, and it's probably going to call an API made by my team and so forth. Bit by myself, so I'm a solution architect there at Alma. Been there now 9 years. I have a developer background, but been doing like AWS infrastructure here like for several years now. I also have a couple cloud certifications, both AWS and GCP. I've used CDK since late 2018 or 18 or something like that, so pretty early on. And current favorite programming languages of mine are at the moment Go and TypeScript. And there's my Twitter and LinkedIn, so at Palo, that's how you can find me there. But yeah, road to infrastructure as code, or basically a cloud journey that I've seen many people take. That first they start with the manual approach. This talk is AWS focused, but I think from what I've seen, it feels that everybody starts with with the manual approach, and they go to the UI and click to there and create resources there and provision stuff. And it's good because it's easy to get started. There's helpful tool tips and most importantly, sensible defaults and things like that. The challenge is that it's not easy to reproduce new environments. If you've done one, it takes a lot of work to create another. It's error prone. We're humans. We might accidentally tick a wrong checkbox somewhere or something like that. And it takes time. So being a developer, we like to script it, maybe using AWS CLI or one of the SDKs like the Python Boto 3, which is probably the most popular one, or some third party using AWS APIs. But anyway, the good thing is that, well, it's easy to get started, easy to create resources, and for many smaller tasks, the scripted way is actually pretty nice. But that doesn't scale that well because at some point you will face challenges that, okay, you've previously created resources. If you're now creating a new resources, how you manage the state of the existing resources and things like that. What if the AWS API for some reason returns an error? How you manage errors, that's up to you. Some resources won't be ready immediately. Instead, you have to wait for them to become ready before you can interact with them. So waiting those is your responsibility to implement. Also, what if the deployment doesn't work? If there's some error, how do you revert back to the old status or old state? So how do you manage rollback and things like that? So that's why instead of telling how to do something, you want to tell AWS what to do. So as an answer to that, it's usually the next step is doing infrastructure with tools like CloudFormation or Terraform. So basically, you're writing configuration files that are declarative, that they describe the desired state. With CloudFormation, it's YAML or JSON, whichever you like. It's easy to automate and it's easy to reproduce new environments because you can use parameters and things like that in the CloudFormation template. So you can use the same template to create multiple environments. So what's wrong with this model then? Well, not necessarily. This works well. This is really very good setup for most people, and I use this quite a lot myself. What I don't like about this is the configuration syntax. It's easy to read, yes, but when you're developing new stuff, it gets annoying because you need to really know and remember what are the valid values to which different resources, and you need to remember what kind of a key names there are, what kind of a values there can be, what is the type of the value, is it string, is it a number, is it an object, is it a list or whatever. And if it's a string, then it might be more of an enum value, so there's maybe two allowed values or things like that. So there's a lot of that kind of things. Of course, there's tooling to help with that, but in the end, it usually is that you still have to you have to read a lot of the AWS CloudFormation documentation. So you're jumping back and forth, documentation editor, and that kind of things. Also, one of the annoying things is that there's no abstraction. It's a lot of details. Of course, the devil is in the details. You have to understand and know them, but at some point it gets frustrating to work with those. So I'd like to have sometimes some abstraction and some high level functionality for these basic features that I'm working with. So here's an example in the screenshot, a simple network, some old CloudFormation file of mine. And yeah, it's 200 something lines, so it could be simpler. It's not bad, but it could be simple. Then there's tools like Tropospheric and GoFormation that basically they generate CloudFormation. So you get all the same benefits as before with CloudFormation, but you write it with real code, and it's sort of a wrapper for CloudFormation in some sense. So you can write code, and it generates CloudFormation out of it. It goes to the right direction, and sorry about that. It goes into the right direction, but it's still missing there's no built-in abstraction there. So for example, in Troposphere, it's 200 around lines of code for VPC. I'm not an expert with Troposphere or code formation, so I'm not an authority to speak about them, but that's just what I've looked into them. But I'd want something a bit more then. So this is where AWS Cloud Development Kit comes in. It's a framework for defining cloud infrastructure using familiar programming languages and built-in abstractions. Those are the two key points. You can also develop your own abstractions or use open source ones. We'll come to that soon. It's the CDK. It's actually an open source project, a bit like Terraform. So it's backed by a company, in this case, AWS itself. And there are a lot of AWS developers working with it, but there's also a lot of community contributions, a lot of pull requests and comments from the community. So open source project, GitHub, AWS/AWS-CDK. You write CDK apps in either TypeScript or JavaScript, so Node.js based, or in Python, Java, or .NET. What makes it possible is this tool called JSII, and it's basically an open source tool that allows you to interact with JavaScript classes from other programming languages. So if you, in Java, there's an example, I'm not sure if it can be seen on the screen properly, it's quite small, but if you have a hello JSII class with public method of say hello, then you can, in Java, you can just say, instantiate the class and then say hello, and pass in some arguments there, and it works. It supports other languages as well, like Ruby and maybe others now even, but at the moment CDK is TypeScript or JavaScript, and then Python, Java, and .NET, which are supported. When you define your infrastructure with CDK, it basically means that you're defining these constructs, and they form this tree structure. So the top level is app, and the CDK application, that's basically the top level construct that holds everything together. Inside it, there can be one or multiple stacks. These are basically CloudFormation stacks. And each of the stack, and actually the stacks, they can be in same region or they can be in different regions as well. So it's pretty flexible, and you can have, I'm not sure if there's a limit of stacks, but you can have dozens or hundreds of stacks there if need be. Within the stacks, there are constructs that are either of type, they are either resources or they are these more abstract constructs that encapsulate some more complex logic. Let's say that you have an S3 bucket that needs to notify Lambda function that some object has been created or updated or something like that. So you could encapsulate that as a construct itself. But the main thing with CDK is the abstraction, I'd say. Some tools, they provide abstraction or some high-level functionality, whatever you like to call it. But if that doesn't work for your use case, you're sometimes out of luck. You have to ditch the whole tool. But CDK, I feel, is really nice in the sense that there's three different levels of abstraction. If the highest level of abstraction fails for you, you can always drop down a level. And that allows pretty flexible development. So if we start from the bottom up, there's the lowest level, level 1, CloudFormation constructs. These are basically AWS resources that map one-to-one to CloudFormation resource specification. So they're basically, there's this JSON file, CloudFormation resource specification, or JSON files anyway. And when it changes, CDK project ultimately generates new CFN constructs, level 1 constructs out of it. And you can call it with, they always are prefixed with the CFN string. So in the bottom right, you can see new lambda.cfn function that would create a level 1 CFN construct. And the API of it would then map directly to the one that you would see in the CloudFormation documentation. Then in the middle, there's a level 2 construct. These are sort of CDK built in, and they usually map to one CloudFormation resource. They sometimes can be multiple, but for this example sake, most often it just maps to one actual resource type. In this example, it's a Lambda function, so you would instantiate it with Lambda that function. What separates it from the level 1 version is that the level 2 constructs, they try to provide you with as much abstraction and as much sane defaults or sensible defaults as possible. So you would only need to pass in like a minimal configuration into it for it to work. So that's the nice thing, that you really don't have to provide that much code. I will show later in the demos that how easy it is to work with the level 2 constructs. Then at the topmost level, there's this level 3 constructs. I'm not sure if that's an official term, but I've seen it in a couple places, and it's a good name. Basically, what it means that you define your own construct. That can be one or multiple resources wrapped into a JavaScript class. And what it means that if, for example, you have that case that you have an S3 bucket that needs to notify Lambda function, you could wrap that as an its own construct, let's say S3 to Dynamo, and then you elsewhere in your code base, you would instantiate it with or initialize it with the new S3 to Dynamo class, and then pass in some props that are required. And then you could even distribute it as an npm module, for example. So that's nice with the level 3 constructs and the abstraction that CDK provides. The level 2 constructs and level 1 constructs, they can be found as the API reference of CDK. It's specific for each programming language that are supported. But this basically gives a nice, if you go click, let's say, AWS API Gateway or AWS Lambda or S3 or what have you, you get to the module, the definition of the module you're gonna use, and that's gonna show all the methods and possibilities with the construct in question. How does these constructs actually turn into an actual AWS resources then? Well, it's gonna use CloudFormation, but if we start from the left side, you have your CDK source code, so your construct tree, and then you're gonna use this CDK CLI, so command line interface tool, and you can run CDK synth. That will synthesize your CDK application into this Cloud Assembly. This Cloud Assembly is basically a package of CloudFormation templates, one or many, depending how you've done your CDK app, and then some assets, let's say zip files think of Lambda function code and things like that, and then some manifest and configuration files. This gets deployed into CloudFormation, and CloudFormation service takes all the does the necessary steps to ensure that the infrastructure is in a state you want it to be. So you get all the rollbacks and everything, auditability and things like that out of CloudFormation service. So it's best of both worlds, benefits of CloudFormation service, but you still get the possibility of writing your infrastructure in real programming language. And because it's real code, you can use your editor/IDE integration, like and other tooling around it. So IntelliSense and Autocompletion is just one of the best things about it, that you get proper autocompletion, like it can say that what are the possible valid values, or it can give you tips that, okay, what kind of interfaces you need to pass around as arguments, and it can highlight errors if you're passing wrong things to somewhere, and you get also some nice tool tips that show like example documentation, how to use some classes and things like that. Also, you can use other tooling, like you could use static analysis tools, like if you're working with TypeScript, you could use TSLint, and you could format the code with prettier and things like that. For Visual Studio Code, I'm not sure if it's available for other editors, might be or might not, I'm not sure, but at least for VS Code, there's a CDK Toolkit extension available from VS Code Marketplace. It provides this nice little tree structure of the constructs. So basically it helps your to model your infrastructure even before you're deploying it into AWS. So you get this high level view of what you're building. So let's jump into the demo. I have here this boilerplate setup already going on. This is a CDK application here running. I'm initializing the app here. I'm importing this demo 1 stack, which I'm initializing here. I'm passing the app I initialized here. I'm passing it to the demo 1 stack class as an argument, as a scope, so to speak. And then I'm also passing this ID string and also some stack props. These stack props basically say that which region and which account I'm deploying into. In my case, I'm deploying into Ireland region here. And then I'm setting some tags just for an example. So let's go to the demo 1 stack. It doesn't contain really anything. So it's an empty stack here. I could say CDK synth. This will output CloudFormation. But as I don't have any resources there, it's just outputting some metadata here. So let's create the VPC here. So VPC lives in EC2 module, as it in AWS, it lives in EC2 namespace. So we have this VPC class here inside the EC2 module. If this would, for some reason, if this would not work for us, we could use the CFN VPC class. This is the lower level class or construct, but I'm feeling lazy, so I don't want to specify that many arguments, and I want to go with the sensible defaults that CDK provides. So I'm using the EC2 VPC module. First, I need to pass it a scope, so this, and then some ID. I'm gonna use, I have this my DevOps Pro Europe here, and then I need to pass in some props. The only required prop for the VPC is the CIDR. So I need to pass in the CIDR here, like so. Now I could run the CDK synth again. And it outputs quite a lot of stuff. It's actually easier if I pass it into a file. So we can take a look what it makes. And here we go. And there's quite a lot of stuff, but you can see it's creating elastic IPs and subnets and things like that, a lot of stuff. So let's take a look. I have this CDK Explorer here and demo 1 here, demo 1 stack. And here I have my DevOps Pro EU demo VPC, like you saw here. And you can see it has created 3 public subnets and 3 private subnets. This is because CDK does a lookup into the region I'm deploying into. And in this case, it's Ireland. It sees that there's 3 availability zones, AZs. So it always makes this highly available setup by default. So it creates public subnets for each AZ and private subnets for each AZ. It also creates 1 NAT gateway per subnet. So in subnet 1, there's not public subnet 1, there's NAT gateway, and public subnet 2, there's NAT gateway, and also in 3. So it's a highly available setup. I could, if I would want to, for example, for development environment, I would like to save some cost. I would say NAT gateways 1, and then I would just run CDK synth, and then I'm going to refresh. So now there is no NAT gateway in the subnet 3, public subnet 3 or public subnet 2, only in public subnet 1. There's NAT gateway here. So it's configurable. And also, if I want to configure subnets myself, let's say I want to create, this setup where I have 3 different types of subnets. So I can pass in, I'm just saving time by copy pasting here, but I want to create public, private, and isolated subnets. So in this case, I'm setting a CIDR mask for the public subnets. I'm setting 27, and for isolated 27, I'm just like pulling this out of my hat. There's no real reason why they are like so. But you notice I don't have anything set up for the private one. That's because most of the cases, well, not always, but quite often there's a reason that you want to have a lot of available IPs in your private subnet because your application instances can be there. So if you leave the private subnet without CIDR mask and then you synthesize it, you will see that CDK will actually calculate what is the biggest possible IP segment to be given for the private subnet, so that there's still room for all the three AZ, or for all the private subnets, well, for all the subnets in all the three AZs. So it's smart like that. So if we now refresh this one, you can see there's now public, isolated, private. If we check out the private and the subnet, you will see there's /18 IP mask there. So it calculated that by itself. So that's pretty handy. And then we could deploy it with CDK deploy. But as it's a bit slow process, sometimes, well, it might take like a minute or so to get the VPC up and running. I have already deployed it, but we could check a diff that what has changed. This might be a bit different, this VPC that I have here, than what's deployed there. But you see, it wants to create a lot of resources. It wants to actually destroy some of them because many of the VPC actions actually require replacement. That's why it wants to destroy some and create new. But you see, this is basically similar than CloudFormation changed it, but in a command line. But if we check the previously created stack and we check the resources, we go to the VPC, we can see there's actually a VPC. When the website loads, there's VPC created, and it uses by default, it names it with the stack name / the ID string we gave it in here in the code. And we can now also check out the subnets. And here we see there is isolated subnets, private subnets, and public subnets. So let's check it out. It's around 30 lines of code. So I'd say this is pretty nice abstraction compared to 200 plus lines in the other kind of implementations. So I like this model. Before I continue, I'm gonna change the directories a bit. I'm gonna prepare for another demo. So demo 2, and I'm gonna put my TypeScript compiler there running in the background. Gonna close couple files and open here demo stack. Yeah. Then what we're gonna build next, a demo 3, is that we are going to build an S3 bucket, and a user will upload a file into the S3 bucket, and once it's uploaded, it will trigger a Lambda function that will actually go and read the file contents from the S3 buckets, and then it will upload the file contents or put the file contents in a DynamoDB table. So that's what we're going to build next. And again, I have cheated a bit that here's some code already, but I'm going to build the most interesting parts here. So I'm going to build a bucket. So it's an S3 bucket. I'm going to pass in the scope. Then I'm going to pass in the ID. Let's call it my DevOps Pro EU bucket. And one thing to note that this my DevOps Pro EU bucket, this is not the bucket name. This is not the this is not the explicit name, because S3 bucket names, they have to be globally unique. I could specify it with the bucket name here, but I don't want, if I say something like this, it's probably existing. So instead, what I like to do is that if it's not important what the bucket name is, I'm going to leave it like this. It means that CDK will use this string and then also prefix it with some random characters as well. So it will be most definitely unique and it will exist. It will be created, the bucket, I mean. Then I'm going to create an DynamoDB table. So DynamoDB table, these are L2 constructs. I'm going to use the same ID but with table. This is going to actually require some configuration. It doesn't work without something. So what's required in DynamoDB? Well, partition key is required. We're going to put partition key in it, and it's going to take a configuration object. Well, for partition key in Dynamo, we need to tell what kind of a type it is. So let's say type, and then DynamoDB attribute type. Again, this is helpful because, well, you see the editor is helping me. I can just choose from existing values. I don't need to sort of figure it out myself. So pretty useful. And also name, I'm going to use the E tag. That's going to actually be the E tag of the file that is in the S3 bucket. Then I need to create the Lambda function that's responsible for all this. So I'm going to say lambda.function, again, the scope, this, and then I'm going to call it my DevOps Pro EU function. That's going to need some properties. What Lambda needs? Well, it needs some code. Let's say I have a code living in demo/lambda. But as you see, I have a, well, where's my cursor? I have this demo-lambda folder here. This is not exactly enough. I need to tell it like this. So lambda.code.from asset and then the path. What this actually does, it's gonna zip this demo lambda directory into a zip archive, and it will upload it to S3 on our behalf, and then use it as the S3 object as the lambda function code. So pretty handy. We don't need to first deploy the lambda, or we don't need to upload the lambda code ourselves to anywhere. It's going to take care of that. We need to specify handler. Well, I've already written the lambda code, so it has this index.handler there, and we need to provide some runtime. So that's lambda.runtime, and then let's say Node.js 12.x. We could specify timeouts and logging and some extra role information there, but let's leave it like that. I'm pretty satisfied. The compiler doesn't warn me about anything, so let's go with the minimal setup. Then we need to tie in together the bucket event to the lambda function. So we need to actually assign these resources into a variable so we can work with them. Let's call that bucket. Let's call this table, and then this fn, because function is a reserved word in JavaScript. So bucket, let's add event notification. Okay, there's some event. We want to add a notification about it. What kind of an event? Well, let's see. S3 event type. Well, event type sounds promising. Object created sounds even more promising. So whenever there's a new object, it will notify something. Well, what's it going to notify? Well, we need this event destination. So we're going to use this S3 notification module and lambda destination, and we're going to pass in the lambda function that was stored in the fn variable. So now we tied in the bucket to function notifications. We need to specify some variables there because I have the lambda code here. It's actually waiting here for bucket name and table name environment variables. So we need to pass those into the lambda functions. Luckily, there is a nice little API called add environment, and we can just say like bucket name, and then we pass in the bucket.bucket name. So pretty handy way of referencing values between different resources. Again, let's do it for the table name, and that's table.table name, like so. Then this is all nice, but we still need some kind of access control because the lambda function needs to access the bucket, and it needs to read from the bucket and write from the Dynamo to the Dynamo table. So luckily, the working with IAM policies is sometimes annoying because they can get really long JSON documents. And for example, in S3, you need to remember that when you put the slash wildcard and when not, and things like that. So it takes quite a lot of practice, and it's not intuitive. For example, for a developer that hasn't really been in the deep with IAM. So luckily, CDK provides this nice API. We can say bucket grant read. So some resource grants some access to another resource. So we just pass in the lambda function there. So bucket grant read fn. Then same thing to the table. We grant write access. We don't need write data, read or write or full access. We only need write data. So write data to fn. And that should be it, basically. We can do clear. We can do CDK deploy. And it's gonna actually upload the it's gonna do a chip of our source code, and it's asking if at the moment it's asking if it's okay to create IAM resources. I'm saying yes, it is. You can actually pass flag to it if it's okay, so you don't need to in CI environment that you would pass the flags there if you wanted to be able to create IAM resources. But I was saying that it's gonna make a chip of the Lambda function. It's gonna upload it to an S3 bucket, and it's gonna then do a CloudFormation deployment. Let's see what's happening here. Doing a live demo with CloudFormation deployment is always a bit risky. It might sometimes take time, or it might crash things. If this seems to take too much time, I might pause the video, but let's see what happens here. It's still creating it. Actually, while it's creating, let's jump to the third and last demo, which is, where's my cursor again? So I'm gonna jump into another directory, demo 3, npm run watch, and then cd demo 3. And the demo tree is basically same than the one before, but we're gonna refactor it a bit. So instead of, in the previous version, we basically created all the resources one by one. But what if that S3 notification feature is something you require in several places? Would it be nice that you had something like this new S3 to Dynamo where you only just pass in the bucket and table, and then everything else is done for you? Well, you can. We can just create like a CDK construct. What construct is? It's a exported class. So export class S3 to Dynamo extends CDK.construct. And that's basically what CDK construct is. It's a class that extends CDK construct. Then I'm going to copy paste this because this is about the same that we just wrote. When we also need to call the construct, define the constructor. So CDK.construct ID string, and then I'm going to say props, and I have this interface here already that basically just takes this bucket and table as props, and then super scope ID, and then I'm gonna paste in the stuff I already had. The only difference for the previous one is that I'm reading the bucket and table from these props, that I'm not creating them myself. So this way you can always you could basically publish this S3 Dynamo construct in npm.js, for example, then other projects just import it and call it like this. Pretty handy, I'd say. You could also improve this by saying that this, instead of construct, this would extend CloudFormation, that nested stack. This would allow that it would actually make a separate stack out of this S3 to Dynamo construct. Where that is a good thing is that if you have a stack that has a lot of resources, because there's a limit of, I think it was 200 resources per stack. So making your construct as nested stacks prevents you from hitting that 200 resource limit. That's something to consider. But I think our demo 2 should be probably, yes, create complete. So let's see what has happened here. So Lambda function, I'm trying to find that there's the S3 bucket, and I'm gonna also open the DynamoDB table. So here's the DynamoDB table. It doesn't have any items. Here's the S3 bucket. It doesn't have any items. I'm gonna go, I have a demo file here. Hello DevOps Pro Europe, let's say 2020 here. Stay healthy, like so. And then I'm gonna upload the file here. Let's see, demo file, next, upload. And then it's a moment of truth. Has it triggered the Lambda function? Let's refresh. And yes, here we go, a working demo. It has the e tag of the file from S3. It has the content, hello DevOps Pro Europe 2020, stay safe, and it has the file name. So the demo worked. So yeah, that was how you basically write, like how you can write these level 2 constructs. So there's not much to specify with them, just the minimum required API, but you can also create your own level 3 constructs that are easier to use if you need to use them in many places. And remember the CDK Explorer toolkit that you can, if you refresh, you can see what kind of resources there are to be created before you even deploy them. So it lets you understand what you're deploying even before you're putting them to AWS actually. One important thing is that you should always test your infrastructure code as it's code. You can use all the software development best practices here. CDK comes with this CDK assert module. You can do unit testing, verify parts of template, verify that the CFN output is as expected. You can check that there's certain resources existing. You can check that there's, let's say, a Lambda function with specific properties is actually defined. You can count resources. You can say that, okay, I want this template to create 3 S3 buckets or something like that. Also, you can do snapshot testing. This isn't something you would do for everything because there are usually dynamic values, but the snapshot testing is nice that you store the snapshot into version control, and if there's a change, your test will fail and it will show this diff what has failed. For example, the VPC CIDR proc in the example screenshot is something that should not change because that's not possible to change it. So that will catch it. So I won't have time to go into details of testing, but CDK assert is really useful. You can test your code in many ways, and you can be a lot more confident that it's going to work as expected. A couple of words about multi-account and multi-environment setups, just that we have many different account setups in Alma. My team uses this kind of a multi-account setup where there's different accounts per product and dev and prod and things like that. But there are also different kind of setups. Even in our team, we have legacy accounts, and then there's other teams that prefer different kind of setups. So how do you sort of provide shared like code for these or shared like functionality? So CDK is great because it allows to do this like versioned reusable library like constructs that you can, or functionality that you can share between teams, because it is real code, so you can use the actual dependency management of your language of choice. So in Node.js world, it's npm. We have npm.js private register, so we can install dependencies from there. And the good thing is that they're semantically versioned, so exact versioning, that's important. A couple examples: we have module for tagging and naming. This is, I like it. I feel warm and fuzzy when there's good tagging. So it reads things from configuration files and environment variables and git states and creates tag values based on those. I have this feature environment cleaning setup, basically a scheduled Lambda that will clean these feature environments from CloudFormation when they're not being updated, let's say in a week. This is still work in progress. There's things to figure out. As it's code, it's easy to make, conditionals and loops and factory functions and what have you. I've never felt really like, I never liked, it has felt really dirty to make conditionals in CloudFormation YAML because it's not native to the language. But in, let's say, TypeScript, it's really easy. I use this stable environment or is production environment quite a lot to, let's say, save money, only make one NAT gateway for development account, and or in production have longer cache time to lives, or longer backup retention periods, or things like that. So pretty useful. If you want to make actually cross-platform CDK constructs, take a look at JSII, PacMac, and DeliveLib. JSII PacMac is a tool that helps you building to these different languages, and DeliveLib is this AWS code pipeline CI setup that tests with different languages and can publish to different registries like npm.js or GitHub packages and things like that. Challenges with CDK: it's based on CloudFormation. If CloudFormation doesn't support something, then CDK doesn't support it. Of course, you can get around it by by using CloudFormation custom resources, basically lambdas. That's easy to do with CDK. That's one thing. Cross-region references. So if you have an app that has two stacks in different regions, you can directly reference values from those because they are different regions. That's a limitation of CloudFormation. But again, you can go around it by using custom resources. It's fresh off the oven, so the core module is stable and the most popular modules are stable as well. That's good. But keep in mind that there are modules that are experimental, so they might break things if you're not careful. Testing your infra code helps a lot. I write unit tests and snapshot tests and verify parts of the templates, so that helps. Ensure your all CDK modules are in same version. Otherwise, hell will break loose if you have different versions, so keep them in sync. Also use extract versions and lock your dependencies, so package lock JSON, that's useful. Here's some resources. I'm hoping to post them somewhere after the conference, but I think Google CDK docs that will lead you to the docs that are pretty good, at least for TypeScript experience. They're rather good. The last link, deep dive into CDK reInvent DOP 402, is a reInvent talk from the two lead developers of CDK. Definitely check that out if you want to dive deeper about this cross-platform CDK usage. And that's about it. Thank you. Follow our Alma developers Twitter if you're interested. And also feel free to contact with me in LinkedIn and Twitter. It's Ari Palo in both LinkedIn and Twitter. So this was first time for me doing this kind of a online talk. So hope you liked it. And yeah, have a good online conference and stay healthy. Bye.